Okay, on to part B. We are solving a system of two equations using elimination. So no longer substitution, elimination. Okay, so elimination, my plan is I want to create additive inverses. So what that means is when I add them up, they'll turn into zero. Okay, I want them to eliminate. I want them to go away. So once I create the additive inverses, I want to add the two equations. I will solve for the remaining variable and then plug that value into wherever I like, okay? Because my answer is going to be x comma y, right? It is a point. It is not two equations of a line. So here's the thing. On this one, I have x, I have y, and I have negative y. If I added these up, the y's would already cancel. I already have my additive inverses. The additive inverses is where you have the exact same number except one is positive and one is negative. That way, once we add them up, they will cancel. That is the point. And this is already set up like that. So we're good. We can just, B1, I always start off easy. So x plus x would give me 2x's. The y's, if I tried to add them, they would cancel. I have my equal sign, and 10 plus 6 gives me 16. All right, so I'll just divide by 2. Divide by 2, and I find out that x is 16 divided by 2, which is 8. All right, now I need to take that 8 and plug it in wherever I feel like it. Does not matter. Let's say we plugged it into the first one. That would be 8 plus y equals 10. And if I solve for y, I would simply subtract 8 from both sides, and y would be 2. That's not my answer. I write my answer as a coordinate point, x, comma, y. So the x was my 8, and my y was 2. So my answer is 8, 2. That is the spot where these two lines would cross. And if you ever wanted to check it, you could go to that the graphing website, Desmos.com. And you could graph both of these lines and see them crossing at the point 8, 2. But on to number 2. Okay, I have 2x minus 3y equals 5, and negative 6x plus 9y equals negative 15. The goal is to make two of the numbers exactly the same except for their signs, opposite signs. So let's say, now you could, I said give it what it doesn't have. So if I wanted to get rid of the x's, I could multiply everything on the top by a 6 and everything on the bottom by a 2. But let's go for their, the least common multiple. So I've got 6 x's and 2 x's. I could change that 2 into a 6 by multiplying by 3, right? So if I did that, 3 times the 2x would give me 6x, and I have to send this number to everything. I can't just multiply the first term by 3. Everything needs to be multiplied by 3. So 3 times negative 3y is negative 9y, and 3 times the 5, so yes, even to the other end, across the equal sign, 3 times the 5 gives me 15. Okay, well, here's the thing. Now the second equation, I did not change it. It was negative 6x plus 9y equals negative 15. Look at that. They're all already additive inverses. See, if I take this and try to add it up, that cancels, that cancels, that cancels. I end up with nothing on the left and nothing on the right. I end up with 0 equals 0. We spoke about this in the first video. If I end up with something that is true, then I have infinite solutions. Infinite solutions. This was just an example of 2 of the same exact line, 2 equations for the same line. So they cross everywhere. They cross at every point. They are 2 of the same line.